Hello friends and welcome again. Now since we are in first two videos we have discussed about some introductory part related to analysis of determinate structures. Now this is third video in which we will continue with the same. So we have already discussed about static indeterminacy. Now this static indeterminacy, it can be studied in two ways: degree of external indeterminacy and degree of internal indeterminacy. So we have already discussed about degree of external indeterminacy. As its name indicates, it is related to external forces, means the reactions. So degree of static indeterminacy, which is denoted by DSI. Now this DSI, it can be studied in two ways: degree of external indeterminacy and degree of internal indeterminacy. So degree of external indeterminacy we have already discussed with some examples in the last video. It is related to the reaction of a structure and is equal to the number of support reactions in excess of available equilibrium equations. And hence a simple formula is there to calculate this degree of external indeterminacy is equal to R minus available equilibrium equations, where R is number of unknown reactions and available equilibrium equations. We are using three equations of equilibrium, but in case of a beam where internal hinge is inserted, we can develop additional equilibrium equation. So in the last video we have already discussed how to calculate degree of external indeterminacy for a structure. Now the second way of studying this static indeterminacy is degree of internal indeterminacy. It is denoted by DSI with I as suffix. As its name suggests that it is related to the internal forces or member forces. If the member forces can be obtained using conditions of equilibrium alone, then the structure is called as internally determinate, otherwise internally indeterminate. If a structure is internally indeterminate, then it is said to have a degree of internal indeterminacy. Now let us discuss different types of structures. First we will start with continuous beam. Now continuous beam, the internal forces in a continuous beam are axial force, shear force and bending moment. These forces can be determined if the reactions of continuous beam are known to us, and that's why continuous beam is internally determinate, having degree of internal indeterminacy equal to 0, because the internal forces can be obtained using conditions of equilibrium alone. For example, here I will consider one continuous beam having a hinged support at left end, then a roller and here at this end let us extend it. Here suppose this is again a hinge support, sorry, say roller support, we will consider roller support. Okay, now if you know the support reactions, easily you can calculate or you can draw shear force and bending moment diagram. If support reactions are known, suppose here this is hinge support, two reactions, roller 1 and this roller 1. So if you know these reactions, you can calculate the internal forces in continuous beam. The internal forces are axial force, shear force and bending moment. So easily one can plot SFD and BMD for continuous beam provided the support reactions are known, and hence continuous beam is internally determinate. We can calculate the internal forces. If we are talking about external forces, that is support reactions, so continuous beam is externally indeterminate because support reactions cannot be obtained using conditions of equilibrium alone, but internally it is determinate. Internal forces we can calculate. Now next is plane frames. The degree of internal indeterminacy for plane frames can be obtained using one simple equation. Degree of static indeterminacy, of course here internal, this is internal degree of indeterminacy, is equal to 3 times C, where C is number of loops. C is number of loops. So let us consider one simple example. Now I am having a simple frame which is fixed at this support, and to this support the frame is having one more support, say hinged. So let us not concentrate on supports, because now we are discussing about internal forces, internal degree of indeterminacy. Now this particular frame is having a open configuration. There is no loop for the frame, and hence for this frame the degree of static indeterminacy, that is internal, because we are talking about internal forces, internal is equal to 0 because there are no loops in the configuration of the frame. Now for better understanding, I will consider one more frame. Suppose this is the second frame. Now in this frame there is one loop, so this is the loop, there is one loop, and hence degree of static indeterminacy for this frame, remember we are talking about internal degree of indeterminacy, is equal to 3 times number of loops, that is C. Since there is only one loop, degree of static indeterminacy internal is equal to 3. So this particular frame is having degree of static indeterminacy equal to 3. Let us take one more example. Now we will consider one more frame. It is very simple to calculate the degree of internal indeterminacy for the frame. Let us consider a frame like this. Okay. Now for this frame there are two loops, first loop and the second loop, right? And hence degree of internal indeterminacy for this frame, degree of internal indeterminacy for this frame is equal to 3 times number of loops. Now there are two loops, and hence the degree of internal indeterminacy for this plane frame is equal to 6. So in this way we can calculate degree of internal indeterminacy for plane frames by counting the number of loops in the configuration of that particular frame. Now the next type of structure is plane truss. The degree of internal indeterminacy for plane truss can be obtained in different ways. It depends upon the type of truss. Now we will consider first simply supported truss. So in case of a simply supported truss, the degree of internal indeterminacy can be obtained using this simple equation: dsi internal is equal to m minus 2j minus 3, where m is equal to number of members and j is equal to number of joints. So let us consider a simple truss. Okay, this is simple truss. How many joints are there? First, second, third and fourth. Let us assume a hinged support at left hand and assume a roller at this end. Okay, now if I ask you to calculate degree of static indeterminacy external, so for external indeterminacy what we are doing? We are calculating the number of unknown reactions 3, and degree of external indeterminacy is equal to R minus number of equilibrium equations available with us. So here R is equal to 3, equilibrium equations 3, hence the structure is externally determinate. Now we are talking about internal degree of indeterminacy. Okay, now there are 4 joints and therefore degree of internal indeterminacy for this particular truss is equal to internal indeterminacy is equal to M. So M means number of members. How many members are there? 1, 2, 3, 4 and 5. So 5 numbers are there. M minus 2 times number of joints. So how many joints are there? How many joints are there? So 1, 2, 3 and 4. 4 joints are there into 4 minus 3 bracket complete is equal to 5 minus 4 into 2 8 minus 3 5, and hence the result is 0, and therefore the given truss is internally determinate as well as externally determinate. It is internally determinate because it satisfies the equation m minus 2j minus 3, m minus 2j minus 3. Now if suppose I add one more member in the same truss like this, one more diagonal member is added. Now m is equal to 6, 1, 2, 3, 4, 5, 6. So here I will write 6, number of members 6. 6 minus 2j, joints remains same. Joints are 4. This is overlap. Remember, this is not a joint. 2 into 4 minus 3. So 6 minus 5. 6 minus 5. Now the answer is 1. It means that now the modified truss is having degree of internal indeterminacy is equal to 1. So it is internally indeterminate to degree 1. It means that the truss is having one member in excess. One member in excess or one member is redundant. So the given truss is statically indeterminate internally, or it is a redundant truss having one member in excess. So in this way for plain truss we can calculate degree of static indeterminacy. Plain truss means this is simply supported truss. This is simply supported truss. There is slight change in the formula which we are using for cantilever truss. Now for cantilever truss the equation is degree of static indeterminacy internal is equal to m minus 2j. So here it is important to know the exact meaning of the terms which are there in the equation. What is mean by m? M is number of members in a truss excluding members in the plane of supports. This is very important. As well as j is equal to number of joints. This is small j. Number of joints except support joints. Now for this we will consider one simple example. Let us consider a cantilever truss as shown. Here this is, say hinge support, and here this is roller. This is roller. And now the truss is having different members. This is one more joint. This is also a joint. This is also a joint, and of course these are the joints support. Now what is degree of internal indeterminacy for this truss? DSI. DSI. This is internal indeterminacy is equal to M minus 2J. This is small j. So how many members are there? Now while calculating the members, you please again read this meaning. Number of members excluding the members in the plane of support. Now these are the supports and this is the plane of the supports. This is the plane of the support and this member is in the plane of the support. So we have to ignore this member. So let us calculate number of members. 1, 2, 3, 4, 5 and 6. So there are 6 members. So M is equal to 6. Minus 2 times number of joints. Now while calculating the joints, let us read this again. Number of joints except support joints. So here we have to ignore the support joints. So support joint, first joint and second joint. So these joints we will not calculate. We will consider joint number 1, joint number 2, joint number 3. So there are 3 joints. 2 into 3. So 6 minus 2 into 3 means 6 minus 6 is equal to 0. And therefore the given continuous truss is internally determinate. The given truss is internally determinate. So in this way we can calculate internal indeterminacy for simply supported truss as well as for cantilevered truss. So we have discussed about plain truss, simply supported. Also we have discussed about frames. We have discussed about continuous beam. Continuous beam is internally determinate. Plain frames, we have to use this simple equation 3 times C, where C is number of loops. Then for simply supported truss, M minus 2J minus 3, and for cantilever truss, M minus 2J. So this is all about the degree of internal indeterminacy. In the next lecture, we will discuss about total degree of indeterminacy as well as degree of kinematic indeterminacy. Thank you.